Hi friends, I'm Dr. Nitin Kumar Saxena. In this video, we will try to solve the problem by using the Norton theorem followed by the definition of the Norton theorem. So in previous video, we have seen that what is the necessity of some specialized theorems after getting the understanding of Kirchhoff's law, KVL and KCL. So if we want a circuit to represent by an equivalent current source, then we go for this Norton theorem. So in Norton theorem, and if we talk about Thevenin theorem and Norton theorem, so in Thevenin theorem we represent the whole circuit with voltage source, while in Norton theorem we represent the whole circuit with current source. The the both theorems, Thevenin theorem and Norton theorems, are equivalent to each other. Mean to say that if you have a Thevenin equivalent circuit, you can transform it into Norton Thevenin equivalent circuit and vice versa also. So let's see first what is Norton theorem. To understand this, the same is that if we have any complicated circuit or any circuit, then we can choose any branch as a load branch, and for this load branch the rest circuit can be changed by an equivalent current source and a resistance parallel to it. So if we have any type of circuit, so a circuit can be represented so for any okay so for any circuit, you choose any one branch as a load branch. If it is given, then okay. If it is not given, then you can choose any one branch as a load branch. So for any branch which you have, which you are assuming as a branch, as a load branch, the rest circuit can be represented by a current source IN in parallel with a resistance RN, and the value of that particular branch will come here as a load resistance, right? So the first thing, what will be the value of IN and what will be the value of RN? So the IN will be the short put load terminal, put load terminal, or you can say short the load terminal, short to the load terminal, and see what current is flowing through this. Okay, what you will do, the load terminal, suppose again I am saying A and B, so I will short A and B and see what will be the value of current that will flow in this branch, right? So this current which is flowing in the short terminals of AB is called IN. So this current is called IN, right? Similarly, how can I find the value of Rn? Rn is same as RTH, which we have calculated in Thevenin theorem. So for getting the value of Rn, we will open the load terminals and see the equivalent resistance of the circuit, keeping voltage source short and current source open. So equivalent resistance across load terminal when voltage source short and current source open. Right. So when voltage source are short, current source are open, then equivalent resistance across load terminal is called Rn. I hope it is clear. So let's see what will be the current IL in this load terminal through this Norton theorem. Formula is IL is given by IN Rn upon Rn plus RL ampere. So if you know the value of IN, Rn and RL, so by putting in this formula you can find the value of load current. Load current is given by the multiplication of load current, so Norton current, and Norton resistance divided by the sum of Norton resistance plus load resistance. Is it okay? So let's see one example and try to understand how can we apply the Norton theorem to find the value of the current in the load terminal. So again I am taking one example. Suppose I have a circuit like this. Again, suppose this is a circuit for which we have to find the Norton current in load 20 ohm. I am again repeating, I can take any resistance as a load. So let's start with this 20 ohm as a load. So if I am taking 20 ohm as a load, so find a value using Norton theorem, right? So first step is to find IN. First step is to calculate the value of IN. How can I do this? Simply I'll draw an equivalent circuit for Norton current. What will be the circuit? So up to this point is the same, but if you see the AB is a load terminal, and in getting the value of IN, what we do? We short this terminal. So we will replace this 20 ohm load by a short line, right? And now we will try to see what current is flowing from A to B or B to A, right? So let us start again. Suppose I am saying a current I is flowing like this. At this point, I will come. Now you see what will happen. You will see that what will happen here now. Current will divide here also and here also. So if current I1 is going there, because it is closed, so I1 is current here, so I minus I1 will go here. At this point, I minus I1 is coming from here, I1 is coming from here, so the total current here will be I. And again, I current is going back to this 15 ohm. Is it okay? So Again, draw the polarity of each resistance. This is plus, minus, minus. Right, now write KVL. First I am going for the big loop. So in big loop, minus 50 plus 25i plus 15i equals to 0. So this is fine. Minus 50 plus 25i plus 15i equals to 0. Solve this. So 40i equals to 50. So I is 3 by 8 ampere. Right? After getting the value of this, now take this circuit, this closed loop. I'm going from this point to this point, then this point to this point, and so on. So when I'll start from this point downwards, so first this voltage source will come. So plus 10 plus 10 times, what is the value of current? I minus I1, and plus 2 minus, so plus sign is taken, and come here, nothing is there, so this is equals to 0. Right? Now you solve 10 plus 10, you know the value of I, 3 by 8 equal minus 10 I1 is 0. So what is 10 I1? Minus 10, or you can say 30 upon 8. So minus 80 minus 30 minus 110 upon 8. Right? So what is the I1? I1 is minus 11 upon 8 ampere. So now you know the value of I1, you know the value of I. Now what is the value of the current in branch AB? If you see, the current in branch AB is I1. You see I1 is coming like this. So the current in branch AB is I1, and according to the theorem, this I1 is IN. Okay, so the value of the I1 is called as the Norton current IN. So what you get the value of I1? I1 is minus 11 by 8. So the value of IN will be minus 11 by 8 ampere. And as I have already told you that we take only the magnitude, we are not bothering about the sign. So what we can write here? We can write in short the value of Norton current. After solving first step, we get 11 upon 8 ampere. Is it okay? So you see, so step 1 is over. Now after step 1, go for step 2. Step 2 is to find the equivalent resistance, which is also known as Rn, across load terminal 20 ohm. So what would be the equivalent circuit? You short the voltage source. This is 25, this is 15, this is 10. So this is okay. So you see, this is the equivalent circuit where we put this voltage source and this voltage source short circuit, and this load terminal is the open terminal. So you see again 25 and 15 are in series, and with this 10 ohm is in parallel. So first step, that 25 plus 15, the value is 40. Right, now this 40 and 10 is in parallel. So 25 is in parallel with, 10 is parallel with 40. So 40 is in parallel with 10, And if you know the formula of equivalent, this is for two resistance which are in parallel, the formula is R1 R2 upon R1 plus R2. This is not a new formula. If you derive it from this, 1 upon R equivalent is 1 upon R1 plus 1 upon R2. Solve this. So R1 R2 will give you R1 plus R2. So when you will reverse, you will get this. Okay, so directly I am using this formula so that in future problems you can use it directly. So 40 ohm and 10 ohm are in parallel. So what we can do, simple, the value of this will be, since 40 and 10 are in parallel, 40 into 10 divided by 40 plus 10. So 40 into 10 upon 50. So the resistance across terminal AB is 8 ohm and this resistance is known as Rn. So value of Rn is 8 ohm. So second step is over. Now what is the third step? The third step is to draw equivalent Norton circuit. So Norton circuit is step 3, equivalent Norton circuit. What is Norton circuit? You know all the values. So put all the values here. IN is 11 by 8 ampere. Rn is 8 ohm. R is 20 ohm. So substitute here and find the value of IL. So IL will be 11 upon 8 divided by 20 plus 8. So 11 upon 8 divided by 28 upon 1. So 11 upon 8 multiplied 1 upon 28. So solve. So 11 upon ampere. So this will be your answer. You can put also if you want in decimals. Right? So have you understood how can we apply the Norton theorem and we can get the value of load current using the Norton theorem? So this is the procedure, and now let us allow me to compare between the Norton theorem and Thevenin theorem. After getting the knowledge of Norton theorem in this lecture and knowledge of Thevenin theorem in previous lecture, if you draw a conclusion, then you can say any circuit, Thevenin circuit, can be transferred to Norton circuit, and any Norton circuit can be transferred to Thevenin circuit. How can we do this? Suppose I am having I am having this Thevenin equivalent circuit having voltage source VTH, resistance RTH in series connected with load RL, right? And I want to make this voltage source to current source. Then what I will do? I will make Norton theorem. I will use Norton theorem, and in Norton theorem, what you have? This. So what you are doing? You are simply changing this voltage source with this current source. And from the theory we know the value of RTH and RN is equal. Right. So value of RTH and RN are equal. And if you see what is the value of IN here, so IN will be VTH upon RTH, right? So if we divide this voltage with this resistance, so we will get the value of current, and that will be the value of this IN. And hence we can say if we have any voltage circuit in series with resistance, so we can change it into the current source having a resistance parallel in it. So this is true not only for the conversion from Norton circuit to Thevenin circuit, but it is true widely whenever you have any circuit in which you have voltage source, and this voltage source has one resistance in its series, then you can convert it as per your convenience, as per the requirement of the question, in this voltage source to this voltage source into the current source. And how will you change it? You will change simply you will change by converting this voltage source into the current source. And you see the direction of the current will be same from negative polarity to positive polarity. If I have like this, if I have the circuit like this, then the direction of the current will be like this. Okay, so inside the source, the current source, inside the current source, the current will flow in the direction from, if I am making from voltage source, from negative terminal to positive terminal inside the source, right? So let us see a simple numerical, and also I am writing here RTH is RL. So this is true when we want to change Thevenin circuit in Norton circuit, or if someone is asking what is the relation between the Thevenin theorem and Norton theorem. Both are the same. The difference is in Norton theorem we use equivalent circuit convert into the equivalent current source. In Thevenin theorem we convert the whole circuit in equivalent voltage source. Finally, if we want to change it again from voltage source to current source or current source to voltage source, we can change according to this formula. Is it okay? So let's see one small example. Suppose in any circuit I have this circuit. Suppose this is 5 volt, this is 15 volt, this is 3 ohm. Suppose this is again 3 ohm, and this is 10 volt. So you see this circuit, the good point about this circuit is that this circuit has one voltage source which is connected with one series resistance 3 ohm, one current source 10 volt which is connected with this resistance 3 ohm. Now I can go in two ways. What are the two ways? Number one, I can change this voltage source in current source, or I can change this current source into voltage source. How can I do this? So we will see both the case. In first case, I'm trying to change this voltage source into current source. So what I say in theory, that if you want to change this voltage source into current source, what you will do? You will simply make a current source and make this resistance in parallel to this. So this 3 ohm, the value of this will be 3 ohm. Rest circuit will remain same. So what is the rest circuit? 3 ohm and 10 volt. 10, sorry, this is 10 ampere. 10 ampere. 3 ohm. Okay, now value of this, since this voltage source is converted into the current source. So first, what is the direction of current inside the source? From minus to plus. So this will be the direction of current source, right? And what will be the value here? the value of this current source will be V 15 upon R, so 5 ampere, right? So this circuit and this circuit both are same, both are same. The difference is this circuit has voltage source 1 and one current source, while this circuit has two current source. It look like different, but conceptually both the circuits are same. In the same way, now I want to change this current source into the voltage source. So this part will remain same. So I am drawing it again. If this will remain same, so 15 volt, 3 ohm. Now you see current source parallel with this resistance 3 ohm. So this 3 ohm will come like this, right? And here minus. So this will change into the voltage source. The value of this resistance is 3 ohm. So it will remain same 3 ohm, right? This volt ohm will come here. Now value of voltage source, since its current is going from bottom to up, so this will be minus, this will be plus, and the value will be V is IR. What is I? 10 into R3, so 30 volt. So you see this circuit is also equivalent to this. The difference is this has now two voltage source, 15 volt and 30 volt. So in this way, all the three circuits are equivalent to each other, are equal to each other. Doesn't matter whether you take this one for your problem, this one for your problem, this one is for your problem. So you can change according to your convenience, according to your requirement, to any kind of circuit. You can change voltage source into current source or current source into the voltage source. And finally, if you will change the circuit, the values in the circuit will remain same in terms of the final answer. Intermediate values will be different, right? So intermediate values will be different, but again, if I am saying okay, solve this, taking this 3 ohm as a load resistance, what will be the value of load current in this 3 ohm? So you either solve for this circuit, for this circuit, for this circuit. If you are trying to find the final value of current in this 3 ohm, which is using as load resistance, so the value will remain same always, the final answer. I hope you understood how can we solve the problems using Norton theorem and how can we transfer the Thevenin equivalent circuit into Norton equivalent circuit and vice versa. And finally, if we have voltage source in the circuit, how can we change into the current source, and if we have current source in the circuit, how can we change it into voltage source. Okay, it's I think enough for this lecture. So let me finish this video lecture at this point. Thank you very much.